Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be doing the post contest analysis of GFG Weekly Coding Contest. So, may I have a quick one in the chat if I'm visible as well as equally audible? According to me, the first question was on the easier side. Today, the second question was a bit tricky. Else, other than that, every question was kind of very easy. Okay, I think we are good to move forward. Okay, if we are good at coding, will we get high package jobs? Yes, because I see your coding skills. Okay, so let me see. Okay, the very first question was binary good. The next question is virus infection, and the third question is label the tree. Am I correct? Just give me a quick. Just give me the ordering now. Just quickly recapitulate the question in your memory and we would start teaching it again now. Like, quickly do it. One is binary good. डेली पीओडीटी के सॉल्यूशन क्यों नहीं अपलोड करते भैया डेली पे अपलोड होती है हमारे से नहीं अपलोड होती तो व्हाट आर यू टॉकिंग अबाउट द सॉल्यूशंस आर नॉट अवेलेबल और इट इज नॉट अवेलेबल फ्रॉम माय साइड व्हाट आर यू आस्किंग okay I think we are good to go so now we would move forward so now I would just present the whole screen and I would just ask you. Okay, so we move forward and we ask that we are given the number of ones in the string as well as zero. Basically, we are given a binary string. What do we mean by binary string? Binary string is a string which is made up of zeros and ones. So in this, we are given 1, 1, 1, 0, 0, and then we are given 1, 1, and suppose again 1, 1, 1. Now there are two types of operation. Either you can add 1, 1 or you can remove 1. And both the cost of both the operation is entirely the same. Okay. So now what you need to do is suppose the first we have set of 1 ones, set of 2 ones, set of 3 ones, suppose set of 7 ones, set of 3 ones, and set of 4 ones. Like it can be like this that the initially the number is 1, 0, again then 1, 1, 0, then again 1, 1, 1. See 1, 2, 3, and then 0, 1, 2, 3, 4, 5, 6, 7. Then again suppose 0. Then we have 1, 1, 1. Then again 0. Then again 1, 1, 1, 1. 4, 1. So we have this itself. Okay. So we can add or remove the same elements. Okay. Now let us discuss the sample test case. Okay. So we can see that here we have 1, 2, 3. So 3, 2, and 1. Okay. So what we can do is we need to equalize something. So make everyone 2. Like increase 3 to 2, make remain 2 as 2 only, and increase this with 1. That would become 2. Okay. So how many operation was needed? Here one in decrement operation, here one increment operation. Increment as well as decrement are treated as same. So 2 operation. That is why the answer to this is 2. Here we can say the number of 1 is 3 and number of 1 is 3. So 3 comma 3 both are equal. So it is done. So basically what we are given the values separated by commas, and then we can increment or decrement the values so that every value is a equal value. बस इतना ही है. 2-4 नंबर दिए हुए हैं सेपरेटेड बाय कॉमा, और हमें सारे नंबर को थोड़ा ऊपर नीचे ऐसे करना है कि सारा वैल्यू सेम हो जाए, और हमें ऐसे ऊपर नीचे करना है कि जो वैल्यूज हम ऊपर नीचे कर रहे हैं वो सबसे कम हो. Okay, am I clear with the problem statement and the sample test case? Just give me a quick one in the chat. Just give me a quick one. Okay, then we would be moving forward. Now, what is the intuition to solve this? What is the way of thinking when we see this question? So when we see this question, we see that the increment and the decrement operation are treated as same. Okay, मतलब number को ऊपर या नीचे करो, it doesn't make a difference. 5 ऊपर करना is equals to 5 नीचे करना. This just means that suppose I want to make 1 converted to 5 and 5 converted to 1. The cost encountered in doing this is also 4. The cost encountered in doing this is also 4. That is why the cost of both is absolutely the same thing. Okay. Now we move forward. Okay. Now we move forward. Then we move forward and then we see that this is important, that whatever increment or decrement we are doing, and we need to equalize, और जो increment or decrement होना चाहिए वो सबसे कम होना चाहिए. So the closest value for everyone would be the average. Like we can set every value to the average of all the values so that the number of modification required would be less. Like हम लोग क्या करेंगे, सारे नंबर का एक एवरेज निकाल लेंगे, उसको सब वैल्यूज को उस एवरेज की तरह बनाने की कोशिश करेंगे. सो क्या होगा, ऑल टुगेदर जो हमारी वैल्यूज आएगी वो सबसे कम आएगी, क्योंकि एवरेज कहाँ स्टैंड करता है, एवरेज कहाँ स्टैंड करता है, एवरेज पूरे नंबर के बीच में स्टैंड करता है. तो सारे नंबर को यहाँ तक लेके आओ, बड़े नंबर को भी बीच तक लेके आओ, बीच वाले वैल्यूज तक लेके आओ, छोटे नंबर को भी बीच तक वैल्यूज तक लेके आओ. इट इज जस्ट लाइक सिंपल. Okay, then we move forward. Okay, we move forward, but we see that average. What do you mean by average? Suppose we have 2, 3 and 5. So if we take out the average of this, then the average of this would be 5 plus 3, that is 8. 8 plus 2 is equals to 10. So 10 divided by 3 is equal to 3.33. So basically if we take out the average, then it might be a scenario that we are encountering a double, which would disrupt the answer. So we need to think of something which is kind of like average but won't give us a double value. Okay, like we can increment or decrement by 1, so we can't ever make a decimal values. So we need to think of something like average number, where that average number won't have decimal values. So to do that would be, we would sort the values and then consider middle element as average. Okay, now this is very simple. It is a very standard way of taking out the average when you don't want the decimal values. Like it is a very standard way of doing that. Okay, so I think I am clear. I would just move forward with implementation. If you're not understanding, just let me know and I would again come back. Okay. Mhm. Yes, I can speak Hindi, English, as well as Bengali. Okay. So I'm a very lazy person, as you all know. So I would just have, instead of str, I would just have s. Okay. Okay. Now, what I would say is vector of int of the L value, length value. Okay. And count is equals to 0. First, we would count all the values, keep it in the vector. Then only we can sort it and take it the middle element. Na? So now what we would do is, we would have int I is equals to 0, I is less than n, and I plus plus. Okay. So now I would say that if a of I, okay, yeah, let's make it a of, okay, s, let's remind it as, okay. So if s of I is equal to the value 1, okay, then we need to increase the count. Okay. Else, what you need to do is, if the count is greater than 0, like suppose after doing this, like suppose it's 1110. So now we came at this value. So the count at this position is 3. When we would come to this 0, okay, when we would come to this 0, the count would be 3. So if the value is greater than zeros, then only we would insert it. Otherwise, we won't insert it. What does difference does it make? Suppose we have 0, 0, 0. So count is equals to 0 every time. So we won't insert it because there is no ones. So we would say that we would only insert if the number of ones is greater than 0. Okay. If count is greater than 0, okay, then we have L dot push back the element CNT, and CNT is equals to 0. Altogether, the total count is equals to 0. At the end, suppose we have something like 0, 0, 0, 1, 1, 1. So we just incremented the value, but we didn't insert it. That is why after all the for loop is done, we would again check if the count is greater than 0. Okay, then again L dot push. So instead of doing all this hard work, just copy the same thing again, and you can remove this part also, like count to 0 again. Like this won't make any difference. Okay, it is done. Now I would sort the values. L dot begin comma L dot n, and then we would take the middle value. So we would say that if there is no ones, like if L dot size is equal to 0, like if there is no ones, then we would return 0 itself. Okay, like no problem needed. Else answer is equals to 1, and then we would say mid is equal to, like this is the average value. So we would try to have every value of the average. No? So we would say L of L dot size divided by 2. Okay, then we would say for int I is equals to 0, I is less than L dot size and I plus plus, and then we would say answer plus equals to abs of L of I minus the value of mid, and then we would return the value of answer. Now we would just compile and run. Like this is just like, suppose we got the value 5, then the remaining values are 1, 3 and 1. Okay, so we would have 5 minus 1, like what is the value, like what are the number of steps required to make it to the average. Okay, now let me try to submit it. Okay, it's done. Give me a quick yes or no, like am I clear or not. Mhm. Just see the line number and tell me the point of time where you are not able to understand. Line number 40. What is the output for the expected string? 0111, like 3 comma 1. Okay, 3 comma 1. So what we can do is, the output for this value is 2, because 3 comma 1. So we would make 1 make it to 2 and 3 make it to 2. Okay, like 2 would be this thing. Yes, median is the average of middle two numbers. What if the length of an array is even? So again, median is the average of middle two numbers. So that would again might give you a decimal values. Like, okay, so just take the n by 2. What if I remove 1? What part you want me to elaborate again? Actually, it is not about saving the cost by using an element from the array, I guess. Okay, other way of seeing it. Both ways are kind of very true. Like, I'm just talking about the intuition. Like, yes, you saw this, then you can move forward to that. Okay, like your reason might be different, my reason might be different. How you came to the solution, your thinking process might be different. Like, you took a different path. I didn't understand line number 40. Which is line number 40? Okay, this value. Okay, this, no. Okay, no issues. So this is like kind of the scenario. Okay, I would explain you. So it is kind of the scenario. Like, suppose we have 1 comma 3. Okay, am I visible? Just let me see. Okay, I'm not visible. Okay, suppose we have 1 comma 3. Okay, so then we have 1 and 3. So the size of the array is 2. So 2 by 1 would be this. Okay, so now what we would do is, we now know that we need to make all these values as 3. All these values as 3. So what we would do is, we would go to 1 and we would say 1 minus 3, and the absolute value of it would give me the points required to have 3. Okay, so it would just give me negative 2, but ABS would make it 2. So yes, 2 is required. Then 3 minus 3, ABS of this is equal to 0. So the total values is 0 itself. Same like this. I explained the test case. Yes, it is absolutely similar to GFG online coding round of a company. I didn't understand the median concept. To be honest, it is not the median concept, because median concept tells us that if the number of values in the array, the number of values in the array are even, then we need to take the middle two values and divide it by 2, and that would be the median. But here we are not doing that, but we are doing n minus 2. Why are we doing the modification here? Because we might get a decimal value. This might be our first reason. The very next reason can be that we would use some value which is already present in the array to reuse that value. Okay. Okay. Could you please explain the 38 if the length of the line number 38, the length of the L is even? Last one was even, 1 comma 3. So size of the array is 2. 2 divided by 2 is equals to 1. So 1 comma 3 would make it to 3. So 3 means I need to make every value as 3. So either of the ways we would get the value of this. Am I clear, Rashid? Just give me a. But actual answer is 2. No, it is not 3. This is not 3. I would tell you that. See, 1 comma 3 and divide. So I would just show you this also. Just see this. See this. So it is not that the answer is 3 by my scenario. So 1 comma 3, I took all the values, sorted. Then size n is equals to 2. So I would need to consider 2 by 2, which is equals to 1. So I would go to the index 1, which is nothing but 3. So we need to make every values as 3. So if I want to make 1 to 3, then I would require 2 operation. If I want to make 3 to 3, then I would require 0 operation. So in total, I require 2 plus 0, that is 2 operation. Okay. So even by doing this, you won't face any issues. Now, am I clear? Manvendra Pratap Singh. We would move forward to the next question. Okay, so quickly recapitulate the question and then I would explain you in the next few minutes. Unga bunga. Unga bunga. Chalo. Move to the next question, please. I moved to the next question. Chalo, I think we can move forward. This question is kind of very easy. Okay, so first I would explain you the scenario and then I would move forward. Okay, so see, the thing is that here in this question, we are shown that we are given a linear path. Okay, okay, and then each person is. So I would just explain you in the other ways, but I would just give you the summary. Each person is infected with a virus in a linear path, and he would affect k other person in that linear path, right side as well as left side. ट्रांसलेटिंग द सेम इन हिंदी वुड बी, एक लंबे लाइन में दो चार पेशेंट खड़े हैं जो अपने आगे के लोगों को भी इन्फेक्ट कर देंगे, अपने पीछे के लोगों को भी इन्फेक्ट कर देंगे. लीनियर मतलब एक लाइन में खड़े हैं, सीधे एक लाइन में, वन डी लाइन. ओके, I should be clear with this. Now, the question is asking us And if we are given this, that what are the patient and what are the patients and what are the values of the values of k, return me the number of patient after the infectious. Okay, like after this infectious is getting big. Okay, so I think we can move forward. So just see this question. Okay, so I would explain you the sample test cases directly. So see, the very next thing is that if we are given one, okay, then this person would affect one person because the number of values is k is 1, and one person in the front. This one would also infect one person in the front and one person at the back. So at the end, we already have 2 patients, and now we have 1, 2, 3, 4, 4 new patients. In total, the answer to this is 6. So now again k is equals to 1. So this patient would infect this patient as well as this patient. This patient would affect this patient, which is already a patient, as well as this patient. At the end, I have 2 original patients and 1, 2, 3 new patients. So the answer to the second test case is 5. Let me just see. Yes, it is 5. Okay. So basically, if you just see, we just need to propagate on left and right. Okay. Seems simple. But a small thing that needs to be understood more. The small thing that needs to be understood more is that if a person is already a patient, that suppose this is 1, this is 0, this is 1, okay, and k's value is equal to 1. So this person would also infect this person would also infect this person. So towards the end, we have 3 patients, not 4. We don't have 4 patients, okay, we have 3 patients, 2 old patients and 1 new patient. So in the implementation, like this is an implementation problem. If you just try to understand it, the intuition, it is very easy, but the implementation, how to implement it, is the main thing. So we need to implement it in such a manner such that this infectious is counted only once. Okay, so now we need to start. So what would be the intuition to solve this would be that we would start thinking, like what I would do is I would start thinking like what are the, do we already have an algorithm which is kind of very similar to this or not? Like either I would design an algorithm or either I would try to just visualize if I already have an algorithm like this or not. Either of the ways is fine. Either I would design, either I already have. So now when I start recapitulating in my mind, ट्रांसलेटिंग टिल दिस पार्ट इन हिंदी, लाइक अभी सोचना स्टार्ट करेंगे कि ऐसा कुछ पहले से है हमारे पास एल्गोरिथम या हमें कुछ नया बनाना होगा. So when we start recapitulating all the algorithms in our mind, we come across a very simple thing which is kind of very similar to this, and that is nothing but breadth first search. Breadth first search kind of is the same thing. Like whenever if that place is visited once, the place is visited once, it won't be visited again. It won't be visited again. Okay. So in BFS, a node is visited only once, nothing else. So yes, we can do that. And BFS is kind of like this. Whatever I say, whenever you need to visualize BFS, visualize it in the form of propagating. So like this is the middle one, this is the next 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 one. So it starts propagating. In the same manner, this is also propagating in a linear path. So propagation is all the two properties of BFS. The very first one is it visited a node exactly once. We want this only. The very next thing is it would propagate, and that is also fulfilled by doing this. So we don't need to design a new algorithm. Yes, you can design a simpler algorithm and that would work too. Okay, many people have done that. But if we already have a well-known algorithm which kind of uses the same idea, then I would use this only. Okay. So now this BFS was the main solution, to be honest here. Now this is the implementation problem, so I would move forward to the implementation. Summarizing the whole thing in Hindi, okay, would be that हमें पता था कि एक नंबर आएगा उसके इधर उधर जाना होगा, बट हमें ये भी पता था अगर इस दोनों के बीच में एक पेशेंट है तो दोनों इन्फेक्ट तो करेगा मगर काउंट शिफ्ट एक बार जाएगा. तो हमें कुछ ऐसा एल्गोरिथम सोचना था जो ऐसा ही कुछ करे. ओके, तो हम लोग क्या सोचने लगे कि ऐसा कुछ पहले से है या नया कुछ करना होगा. फिर हमें याद आया बीएफएस है. बीएफएस वैसा ही कुछ करता था, वो एक नोड को एक ही बार विजिट करता था, पहली चीज. दूसरा, वो रेडिएट करता था. ओके, और हम भी यही कर रहे हैं. हम लोग भी अपना इन्फेक्शन रेडिएट कर रहे हैं इन अ लीनियर पाथ. वो ग्राफ पे है, ए लीनियर पाथ पे है. सो वी कैन डू दैट. ओके, so yes, we can move forward and we would move forward to the implementation directly. Now the next two problems are kind of very much towards the implementation specific problem. Okay, just let me know if you are facing any issues. When I was doing last week that this year, the first Jan, yeah, the first Jan stream itself. Okay, so okay, yes. So just tell me quickly if I'm clear or not. Just give me a quick one. It is correct approach for various infections that iterate over the array if you connect the forward and back iteration. Yes, we can do that. But for a single element, we are iterating front and back. So for a single element, it might be a scenario that we are iterating all the front elements and all the back elements. This just means that we are visiting all the elements. So for one infected person, we are visiting n elements. So for n person, we would be doing n square operation. Okay, just tell me quickly if I'm clear till this point or not. बातें समझ में आ रही है या नहीं? नहीं समझ आ रही है तो बताना आपका काम है. Line sweep algorithm work as well. Yeah, line sweep algorithm would also work as well. You don't need to worry. Yeah. Line sweep algorithm can also work, and that would be more simpler also. But many people don't know about line sweep algorithm. It is a kind of underdog algorithm. It's very easy, but kind of underdog. That is why I didn't took that into consideration. But everyone knows about BFS. Like, it is a well-known algorithm. It is not an underdog algorithm. Okay, we have this. Then we have vector of Boolean, and we would visit. So BFS, what it does is it uses a visited array so that we visit each node exactly once, and we would do the same thing here. Okay. Okay. So now we have T Q. Okay. It just makes the implementation a bit easier. Pair of int, comma, int, and then we would have TQ, and then we have int answer is equals to 0. Then we would for int I is equals to 0, I is less than n, and I plus plus. First, we would insert all the infected person. Okay. So I would say if the current person is an infected one, if the current person is an infected person, then we would say q dot push back. Okay, the I comma 0, like the time required to infect the infected person would be 0. Suppose I'm already in love, so the time required to make me fall in love would be 0. 0 efforts are required. That is why the source would be having 0. Next, we have visited of I is equal to the true value, and we have answer positive. Okay, then we go down and then we start the normal q dot size. Okay, then we would start the normal BFS. First, we would take out the front. So pair of int comma int. By the way, you can directly use auto too, and that would solve the same thing. Auto, just instead of pair of int and int. Okay, and then we have pop front. You can use a queue also. It would solve the same purpose, but a DQ is kind of a generalized way of implementation. Like if you are an online judge, you can prefer DQ. Why? Because in DQ you can use it like an array also, as a queue also. Like everything, insertion from the front, removal from the front, insertion from the back, removal from the back, seeing the front, seeing the back, everything is present. Okay, so if f dot second is less than k, if f dot second is less than k, then first we would say that f dot first, okay, f dot first minus 1 is greater than equal to 0 or not. If it is greater than equal to 0, okay, so first we would visit it of f dot first comma minus 1, and we would make it to false, okay, greater than equal to 0. Now if it is false, then what we would do is we would say q dot push back f dot first minus 1 comma, okay, f dot second added to 1. Okay, I should be clear till this point. Next we would visit it also, visited of f dot first plus 1 is equal to true, and then answer positive. Okay, then we go down a bit, and then we say if f dot first plus 1 is less than n. Okay, so it's just like doing okay, I would explain you that each part of it. Just let me write it. Okay, so f dot first plus 1. Let me copy this now. Then visited of f dot first plus now visited of if it is less. Again, I would ask same thing. Like this part would be the very same thing. Like again visited of f dot first plus 1. Now if it is again equal to false, okay, then q dot push back f dot first, okay, plus 1 comma f dot second plus 1, where the visited of f dot first plus 1 is equal to true, and we have answer positive. At the end, we would just return the answer. Okay. Now let me see if the sample test case is correct or not, or how many mistakes am I making. Okay. So see, let me submit it and then I would talk about it. Okay. So this is correct. I'm pretty surprised too, because a lot of things was needed to be written. Okay, first we say that if I am in love, the time required to make me fall in love is 0, and I am already in love. Now my question is how to make others fall in love. So what I would do is I would first take out the very first element in the queue. That is what we do in BFS. Next we say that if f dot second is less than k, that the new element we are trying to visit, if it is within the range of this or not. If it is within the range of this, then only we can visit it. Na? That is why we would do this. Okay. Next we say that if f dot first minus 1 is greater than equal to 0. So it might be a scenario that it is the very first element. Suppose I am only the very first element. Okay, and I'm trying to look forward. I have nothing. So in the same manner, we would say that if the element I'm trying to see is within the bounds or not. If it is within the bounds, then only we are coming to this position. If it is within the bounds and it is not even visited up till now, then what we would do is we would process this, visit this, and infect this person. Process this for further queries, for the further manifest. Visit this and implement this. First, we talked about if we are looking in the front. Now, it might be a scenario that I'm the very last person, I'm still trying to look back. So I have no one. In the same manner, I want to see that I have some people behind my back or not. If I have some people behind my back, it just means that I'm within the bounds or not. If I'm within the bounds and I have not been visited up till now, then I would process myself, mark myself visited, and increment the number of infected person. Within the bounds, not visited up till now, within the reach of the KA, infect that person and process further. Am I correct? Just give me a quick yes or no. Are you clear with this or not? So I'll just present this here. Just tell me the point or the line number where you are not able to understand. What is the second element in pair? Second element is nothing but the time required. Okay. So now all clear. समझ आ रहा है. Eagerly waiting for third. Okay. When I want to revise previous solved problems on GeeksforGeeks page, it will throw. I want to revise. Okay. Okay. I have bookmarked it. Sir, in question number 2 in long test case, when I tried to test it, I got correct output, but I submitted shows wrong output. In fact, I copied from that input only. Actually, it happens in every compiler. Like in every online compiler, this happens. So be ready with that. Even if Geeks for Geeks day after tomorrow is able to solve this, I don't think it would be the like every compiler would do the same. So be ready for that. So the best thing what you can do to combat this is that you have an offline setup. Best is that you have an offline setup. You don't use custom input and all. Could you explain from where can I? Could you explain line number 28 again? Yes, absolutely. What is line number 28? F dot second is less than F dot second means F dot second is less than this just means that I have a particular radiation, like I have a particular dimension. Okay, like I can infect K person on my front. More than K person I can't. So I'm just trying to look if the person who is sitting in front of me is within my range of making him contagious or not. Like वो हमारे radar में है कि नहीं to make him a patient. Okay, we want to check if he is in the radar so that we can make him a patient or not. Am I clear? Are there any doubts that still persist? Any more queries I have? I would wait for the next 1 minute. So I think no one is willing to reply me. We will simply move forward. Mhm. Okay, just quickly read the tree. And then I would explain you the question in the next 1 minute. Sir, I have don't knowledge about. Sir, I don't have knowledge. Can you explain the approach in short? Just learn about BFS, solve some few problems, and then come back, see the video. If you are still not able to solve, connect me on LinkedIn with the username as Siddharth Hazra. SIDDHARTHAHAZRA. And then ask me, I would let you know. Okay, I'm done. The intuition for this question is kind of very easy. Okay, so I would just share the whole screen. Okay, so it is given that we are given a rooted tree. Okay, we are given a rooted tree. Now, the very next thing we want to do is that for each node, just let me have this. Yeah, for each node, just see this condition. Okay, just let me show you. You have to level the vertex such that if the level of vertex is x and there are m nodes in the subtree of that node, then there must be exactly m minus 1 by 2. So we want exactly m minus 1 by 2. What do you mean by m minus 1 by 2? This is nothing but floor value of m by 2. This is for general information. The very next thing is, what is m? Suppose for a particular node, the number of nodes underneath is the value of m. Okay, the number of nodes underneath is the value m itself. Okay, I should be clear with this. So we want exactly this many number of nodes. Suppose the value of this is x. So we want exactly all the nodes in the subtree of this to be less than x. Okay, so the new values over these point should be less than x itself. Should be less than x. We want this. So if we want this, what can be the way of solving this? Don't just see the sample test case, because there are multiple solutions and you can return either of them. If there is a solution, if there is that this thing is mentioned in the question, try to not see the sample test case solution, because they are meant to confuse you. Okay, now we move forward and we see that we need to solve this. Now try to think this, that suppose we want, like, let's remove this. Suppose we have a family. Okay, like family tree is the most akin thing of tree. Suppose I have a father and below are the two children. Okay, let's try to have the very simple concept. Suppose I tell that all the children of this person, all the children of this person should have a lower pocket money than the father. Like the child should have less money than the father. This is the question. child should have less money than father. Okay. So, just for example, suppose a child father has 100 rupees, so these two both can have 99 rupees. Okay. In the same manner, the father can have 2 rupees and these all can have 1 rupee. Okay. So if you just, and this is to be done in this question also, and this same thing is to be done. But if you observe that if we are assigning a value 100 here, okay, which is easy, tell me. The first approach would be we are assigning 100 or any values to the father, and then we are seeing that what value is not given towards the father, and then we assign it, suppose 1 and 2. This is the first approach that we can do. The very next way of seeing that would be that I would start assigning values from the bottom, so that I don't need to see if this value is already assigned or not. Like हमें देखने का वो प्रॉब्लम ही हट गया कि ये पहले से है या नहीं. क्यों? क्योंकि हम लोग नीचे से ही स्टार्ट करेंगे, नीचे से ही 1 2 3. Okay, like if we start like this 1 2 3, so definitely each parent would have greater values than the child. If we start assigning from the bottom, each values in the bottom would have less values than the top. I should be clear with this. Just give me a quick yes or no that we need to start from the bottom. So, okay. Bro, I have sent you a request. Please accept Kalina. Okay, sure, I would accept it. I think we will do DP on trees. Absolutely not an issue. DP on trees is not required. Okay. So see, this is very easy that we would start from the bottom. Okay. So whenever we need, so starting from the bottom, we need to assign. Just try to think it this way. I need to start assigning when I need to travel from the bottom and I need to start assigning. Now for traversal, there are 3-4 algorithms. The very first most basic would be DFS and BFS. So DFS is a depth first search. First it would go to the bottommost and then it would come back to the top. BFS is kind of radiation kind of visualization. So which one is more favorable to us in the scenario of this? Obviously depth first search. Why? Because it goes to the very basic leaf node and then it starts going to the top. Okay, like it would go to the very leaf node and then it would start coming to the top. So what we can do is, it would be an implementation heavy problem because of the constraint that it wants exactly m by 2, exactly floor of m by 2 values. Okay, we need to respect that. But if if we need to remove this constraint, then DFS would be our best friend. We would start from the bottom, start assigning the values, and start the values from 2 because we want start assigning values from 1 or 2. Okay, and just go till the top, and that would be done. The only constraint we need to respect is floor of m plus 1 by 2, m minus 1 by 2, m minus 1 by 2, which is nothing but floor of that value, and it's done. Simple enough. ट्रैवर्सल करनी है. ट्रैवर्सल कितने तरीके के हो सकते हैं? 2 तरीके के ट्रैवर्सल. 2 तरीके के ट्रैवर्सल होते हैं. सो पहला दिमाग में ट्रैवर्सल के लिए क्या आता है? BFS DFS आता है. BFS हमने देखा कि वह इस तरीके से विजिट करता है. DFS हमने देखा कि वो सबसे पहले नीचे जाती है फिर ऊपर आती है. दैट इज व्हाट इट इज नोन एज डेप्थ फर्स्ट सर्च. दिस इज द इंट्यूशन फ्रॉम द क्वेश्चन टू द सॉल्यूशन. Solution is not that greatly important, but your main takeaway from this video tutorial would be the part of thought process. So am I clear with your thought process or not? Like how this DFS thing would pop in your mind. The implementation would definitely become a little bit heavy. It is a last problem. Okay, simple DFS hota tha ye last problem rehta bhi nahi. It is the last problem. We need to respect some constraint. It would be an implementation heavy problem. Implementation, you would be able to get the half of the idea. But if you're able to get the idea, then learning the implementation is just a matter of months. So first tell me that if the DFS idea is clear to you or not. Does it make sense? Does it make sense or not? It makes sense. Okay. So now if it makes sense, then we would move forward to the implementation. This is the last question. If you face any problems in the implementation, learn about it a bit. Still not, after 2-3 months, ask me in the LinkedIn. Like, first, give 2-3 months to your implementation skill, because you just came here, then you thought ki I would be very good with implementation for even the third problem. This is not possible, na? If coding was this easy, if coding was this easy, then every other person out there would have been a coder. Simple enough. But as a teacher, my work is to make the idea easy. But implementation is all about hard work. No mentor can make you learn implementation. No mentor can make you good with implementation and all. Okay. Implementation, if you type codes, then only you would be good with implementation. So we would have a DFS function which would return me all the visited values. Okay. So I would take a current value. I would take a vector of int of and adj, because it is nothing but adjacency list. Okay. So we would make an adjacency list. We would pass an adjacency list with the current value, just like we do with the DFS. We pass the whole graph and we pass the source of it. Okay. Now we would say that if graph of current dot size is equal to 0, we made it to the very bottom. If we made it to the very bottom, then we would have vector int a, and then a dot push back the value current. So this is the very initial value that we want to assign, and then we would return. Like, suppose there is only one value, so we would just simply assign and then we would return. Okay. Now we move forward to the main thing. So now we would have two, one auxiliary and one data structure, that is a comma temp itself. Okay. So last question, please just be with me for the next 5 to 10 minutes and then it would be done. So for int I is equals to 0, I is less than g of current dash I, comma, the graph. Sorry, for I is less than g of current dot size. Yes, this is fine. And then we have I plus plus. Then we have temp. So first we would assign all the values in temp. We would reverse it, and because we need to respect the constraint of exactly m minus 1 by 2, we need to respect the constraint. Okay, if we need to respect the constraint, then we would have all the values assigned, and then we would just reverse it, take only n by 2 elements. Okay, just simple enough. This is the idea. So first we have util. Okay, and then we would just pass it g of current dash I. Okay, comma, the graph itself, and then we would reverse temp dot begin, comma, temp dot end. Okay, so now we would say that after all this is done, after all this is done, we would say that while we have values on temp, while temp dot size is greater than 0, like we have some values greater than temp. Okay, if we have some values, we would just push it to the a value. Okay, push back temp dot back, like we would start pushing from the back. Either we can reverse it and then we would start pushing from the back, and then temp dot pop back itself. Okay, now The very next thing is that we would have sz is equal to the value int of a dot size, okay, sz divided by equal to 2, and then we have a dot insert a dot begin, like just to maintain the constraint of this lower one, okay, a dot begin plus sz comma current, okay, and then we return the value a. Okay. So this is it. So what are we doing here? I would just quickly repeat. If this is the very first node, we would just assign it and then we would return it. If this is not the first node, then we would iterate it. After iterating, we would call it for all the sub values, like what we do in DFS. We start with the root and then we call subsequently recursively called for all the childrens. And here we are doing the very same thing here itself. Okay. After getting the values, we are reversing the values. Then we start taking the values and we start assigning it. After all this is done, to maintain that exactly m plus 1 value exactly m minus 1 value m minus 1 divided by 2, or the floor value divided by 2, is less than equal to m, less than equal to x, we just do this. Okay, we just assign it to the value current. Okay, so all the values other would be less than this. Okay, and then we return this value. Now for the label tree, we would just build up the graph and then we would call it and then we would return the answer. Okay, I'm a very lazy person, would make it n. Okay, then we have vector of int, like this. Okay, vector of int, and then we have of size g of size n. Okay, then we start from the first node, because the first node has the parent as -1, like we are given a parent array, but the root node does not have any parent and it is given in the front. So we start from the second element, which is not a root node. Okay, because there is no point of traversing the root one. Root doesn't have any parents. Only for int I is equals to 1, I is less than n, and I positive is equal to g of p of I dot g of p of I dot push back the value I itself. Okay, then we have vector of int m, and then we have util, and then we have simple graph. Okay, then we have nothing but vector of int of rest of size n. Okay, then we say that we would just add one values, because we are starting with the value 0, where it is told that we want all the values to be greater than 0. Okay, so we would just add 1 to everyone. For int I is equals to 0, I is less than n, and I plus plus. Then we make res is equals to temp of I is equals to I plus 1. Okay, return the value of res. Now let me just see if I'm getting correct value or not. Okay. Today I didn't make silly mistakes here. Okay. So now just wanted to tell something, because I was receiving it for the few months. Okay. So what so why reverse stem? Okay. On the stem test cases would help me to understand it better. So dry run on some test cases would be a very long procedure, because I need to have the parent array, then I need to have the adjacency list. After that I need to start a DFS with every other values, so it would be a little bit tiresome, so you need to do it yourself. Why reverse stem? Because we start taking from the back. Okay, just this. Okay, any more queries you have? Okay. Okay. So basically, so what happens is basically I was receiving it for the last few contests. So I understand that many people tell that after this point of time I'm not able to understand. After this I'm not able to understand. It's fine. Okay. But if you're not able to understand the implementation, then the problem is on your end. It's just a reality check. Okay, because if you have seen codes, like if you are typing and all, then learning about the syntax is very easy, like why this is done. But if you have a problem in understanding the idea, my main work is to give you the idea, my main work is to give you the intuition, my main work is to give you the solution, but your entire focus is on the implementation. And yes, it's very fine that you don't understand, like you only, like some people only give negative feedback. Okay, but yes, we do want positive feedback, but let's accept the reality that no people don't congratulate you when you have done good, but people point out you when you have done bad. Okay, so when you don't understand the implementation, you do point out, but whenever you point out on the basis of not understanding the implementation, make sure you just try to have the thing that I'm understanding the idea from the same teacher, but I'm not able to understand the implementation from the same teacher. The problem is with me or with someone else. Okay, what would it be? So the last problem was a C problem, I can say. The first problem was very easy, on the very easier side. Okay, like A problem, B problem, C problem. Div 2 A B C. Okay, please do a try run. It would be a very big task. Okay, you have been super instructive. Thanks a lot, brother. Any more query? What explain the insert statement? Insert statement is nothing but inserting the element at a particular position. Okay, this is done. Inserting the element at the position size, inserting the value current at size. This is the functionality of insert. Now, why do we take a temp array? We take the temp array, first we do it, then we reverse it so that we start from the very small values and then we just start inserting the values. Okay. Any more queries you have? 1500? Last problem, I can say it is 1500. Why? Because it was an implementation heavy problem. Idea was simple but it was an implementation heavy problem. Not 1500, around 1400. This problem would be hard, right? Yes, it is basically a hard problem. Okay. So if you were in this video for this point of time, consider liking and commenting on the video for better reach of this video. And if you're watching the recorded version of the video, just make sure you comment so that this work could be justified. So I didn't want to point out anyone, or I'm not trying to take anything on my own. Okay, basically if I know my work is being done on a good way, I really, like, I'm not that much affected by the negative comments. Yes, we are humans, we might say that I don't care. Okay, but in reality we do care and I accept that, but I try to just look past it. Okay, but my main idea was that I saw some students on the offline, like know some students who follow me offline. Like I know some students of mine offline also, and they told me, like, sir, आप जब implementation आते हो ना, तब आपकी बात समझ नहीं आती है. So when they said it, it gave me a hit. Okay, like, sir, आप जब implementation में move करो तो आपको समझ में नहीं आती है. This is because you have not implemented a lot of code. If you're understanding my solution, then implementation is just a matter of syntax. Chalo, I think we can move forward. I need to have my dinner. I'm super hungry at the moment. Was a contest at 8:30, so I didn't even have snacks also. Chalo, bye bye. Take care, everyone. Thank you.